In this video, we're going to talk through Objective 2, which is drawing the graph of a polynomial if given the equation in factored form. And so, in the previous video, we worked through, if given the graph of a polynomial, can you then tell me the factored form of the polynomial? And follow the steps to find the factored form. So technically, now we're going to be working backwards to draw on our own xy axis if given the factored form of a polynomial right here. So it's a little bit more in depth and maybe a little bit more difficult, but it's still, once you practice it and if you follow it step by step, should be pretty straightforward. And this is the final topic or final objective of this topic of drawing polynomials. So this is technically the new learning as well. You haven't seen this yet. And so I'm going to do an example of how I would want you to do this. I've listed out the steps in red right next to it, so I'm going to take this step by step in order to be as successful as possible at doing this objective. So please follow along as I go through this. The first thing I would do, if given this polynomial g of x equals negative x plus 4 squared times x plus 1 times x minus 2 times x minus 4 squared, is consider how many factors. That's a question I always ask myself, how many factors exist? Because if you notice, the first step in this process is to identify the roots. And I have to consider the relationship between factors and roots. And so I would notice that there is 1, 2, 3, 4 factors. I know that they're factors because they have variables, and there's an operation like x plus 4 within the parentheses, so that is a factor. Roots are x equals something, so that's the relationship. So I have to take it from factored form to root form. So I'm going to go ahead and do that. I'm going to show you my thought process for that. So I'm going to do step 1, which states identify the roots with multiplicity. I'm going to alternate how I do this because I didn't leave myself a lot of room. X equals, and then finally, up here, x equals. So I need to find out what the roots are, or x equals, because each factor has a root. Now, two ways you can do this. Factors, technically, when you solve or find the solutions, you set them equal to 0 and solve. Or another thing you can consider is this x, there's only one number that you put into that x that would make that factor 0. In this case, blank plus 4, so positive 4, it would have to be a negative 4. X equals negative 4. Negative 4 plus 4 is 0. And this power then, remember, the power of 2 means that it's a multiplicity of 2. So 4 multiplicity of 2, negative 4 multiplicity of 2. Again, if you don't remember how to do that, I could set the factor x plus 4 equal to 0 and isolate or get my factor, or x, variable by itself. So I'd have to subtract 4 on both sides. So then I have x equals negative 4. Same process. But I want you to be able to jump to the consideration of what makes the factor 0. In this case, x plus 1, it would have to be a negative 1. And there is no power, so whenever there's no power raised to that factor, I can assume, like right here, there's no power written, I can assume that it's 1. So it has a multiplicity of 1. I'm going to erase that and move it a little bit to clear it up. Finally, moving on, x minus 2, it's going to be x equals positive 2 because a negative will switch to a positive. And then it has a multiplicity of 1 again because there's no power up here, so I can assume that it's 1. And then finally, x equals positive 4 with a multiplicity of 2 because of that power of 2. So I've identified all of my roots. There's 4 factors, so that gave me 4 roots, but again, consider the multiplicities, so there's more, like this negative 4 shows up twice, so technically there's 2 negative 4s. But I've identified all my roots. Check. Moving on, I'm going to plot these roots. And again, the multiplicity doesn't come into play until I start drawing this, because if you remember, even multiplicity, or multiplicity of 2, bounces off the x-axis, and odd multiplicity, or multiplicity of 1, goes through at that specific root. So the first one, x equals negative 4. I'll draw a dot right there at negative 4. So I'm not going to consider the multiplicity till later. Next one, x equals -1. I'm going to draw a dot, and I like to work left to right. Doesn't necessarily matter, it depends on how they give you it in factored form. At -1. Moving on, x equals 2. And then finally, x equals 4. So I have done step 2. I've plotted the roots on the x-axis. Step 3 is to find the y-intercept. Now, this is new to this process, but we've found the y-intercept of quadratic functions before in Module 2 and Module 3, so you should remember how to do this process. And if you remember, the x value at the y-intercept is always 0. Alright, so that just tells me that I can input 0 into the original function up here for all of my x's to get my y value or y-intercept. So I'm going to show that work, y-intercept, and I'm going to input 0 instead of x's. So I have a negative, and then 0 plus 4 instead of x plus 4, and it's squared, times 0 plus 1 times 0 minus 2 times 0 minus 4 squared. So please write that down, and then please, you can enter this in exactly like you see it on your calculator. If you do that, it should give you the right answer. So please take a moment, pause the video if you need to enter that into your calculator to make sure you're doing this process right. So when I enter that in the calculator, that's going to give me, I know my x value is 0. It's going to give me my y value of 512. And I understand that is a gigantic number, and it's going to go off the graph because the graph only goes to 7 on the y-axis. But that's totally fine. Again, polynomials, it calls upon thinking outside the box or just thinking a little bit abstractly, but a polynomial can indeed go up to 512. It's just going to be a little bit, it's going to look a little different to draw that. So I've done step 3, I've found the y-intercept. Part of step 3 is also to plot it. And how I want you to do that is just, here's 7, I know that the next one is 8, so you could just go a little bit above there and identify for me then, if it doesn't fall exactly on where you drew the dot, you have to write that I know that that's 0, 512. I know that my y-intercept is that. So you have to show me that you know that if you draw a dot that's not necessarily on the y-axis. So I have found the y-intercept and plotted it. Now I have to determine, the next step is very crucial as well, determining if it's positive or negative, because this helps me to start drawing my polynomial. If you remember, positive polynomials end going up, negative polynomials end going down, so this is going to help me to draw the tail, or the end point. So I look to the beginning of my function, right here. And I can do it in red too, right here. I see a negative sign. That tells me that this function is a negative. If there was no negative sign, if there wasn't a sign in general, then it would tell me it is positive. Like if you look down here, you have two I do's. If you notice, that's negative, but over here, there's no sign. Chances are that one's not going to be negative. So I know that it is negative. So I have found the direction, and I've kind of made a mess here, but the direction is negative, so that tells me it's going to go down. The ending going down. So now I'm going to draw the tail, and the tail again exists at the end, and all that means is it's the last x-intercept. First, second, so first one here, second one, third, fourth, last one. I'm going to draw a tail and draw arrows to tell me that it's going to go all the way down to negative infinity. So I have drew my tail. Alright? Again, this is just a sketch, so it doesn't have to look perfect. Now, that's step 4. Done. Step 5 is working backwards to draw the polynomial. Now, this is where you consider multiplicities, and that's why it was so important to do it. Step 1, identify the roots with multiplicities. Again, remember, it bounces. You have to consider, does the graph bounce or go through at each root, depending on the even or odd multiplicities. So, I'm going to work backwards, and I'm going to change colors just to show you my thought process. You don't have to draw these dots, but this is what I think when I do this. Is I start at the tail, all right? I work backwards. I understand we usually go left to right, but in this case, I'm going to work backwards. This is my mind traveling up here. I see that it's going up, 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 up towards this root, that solution, all right? So again, you don't have to draw those dots, it's just my thought process. I've approached this solution. That's x equals 4. That's right here, I've already identified it. X equals 4 and the multiplicity is 2. An even multiplicity tells me that it's going to bounce off of the x-axis at that point. Bounces off, all right? So at this point, I have bounced off. And hopefully you'll get good at this to where you won't have to pick your pencil up. I'm just picking it up to show you my next thought process, all right? It bounces off and goes down. I don't care how deep you make this valley. All I care about is you have to connect all of the dots, all right? And you also have to connect to the y-intercept, so make sure you do that. That's step 6 right here. So, I don't care how deep the valley goes. I just know I have to come back up eventually before I hit the next x-intercept at 2 because all the dots have to be connected, all right? So here's x equals 2. This is, I go back to step 1. X equals 2, and its multiplicity was 1. Odd multiplicities go through. And if you're doing this right, it should connect because I do have to go through because I have to, don't forget about our y-intercept up here. I have to also go through the y-intercept. So it makes sense that it would go through at this point at x equals 2 and not bounce off, because if it bounced off, it would veer down and it wouldn't hit the y-intercept. So far, so good. I'm doing it right. I come on up through the y-intercept, and then the next dot here at x equals -1 tells me I have to come back down before that point. I'm going to draw it all the way to that point and pause. All right? X, I have to go up and look at x equals -1. What's the multiplicity at x equals -1? And it is 1. So it's odd. So I know that it goes through. And at some point, again, I don't care how deep you make that, at some point, it comes back up to the final root, x equals -4. And I did that one here. And its multiplicity was 2. So that tells me it's even. That tells me it's going to bounce off. And I draw my dragon tail. I like to call it that. You can call it whatever you want, but I draw the dragon tail to finish it off. So now I started with my end, I worked all the way backwards, and I drew my beginning dragon tail. So I just did step 5, and I did step 6 through that process. I just said make sure to draw the graph through the y-intercept as well, because sometimes that can be forgotten. Now, the last thing to consider is the degree. All right? And if you remember, just to check our work, this is kind of just to check the understanding. The degree is adding up all the powers. I have a 2 right here, a 1, and a 2. 2 plus 1 is 3, plus 1 is 4, plus 2 is 6. So I have degree 6. Let's see if this matches then. Degree 6 is an even number. And what are my endpoints doing? This one's going down, and this one's going down. So I have done this correctly. Because when both of the endpoints are doing the same thing, I know that it's even. So I have drawn this exactly how I should, following it step by step. Again, if you notice, my picture is not the best. This is just a sketch. All I care about is you identify the end correctly, you identify the x-intercepts correctly, the y-intercept correctly, and that your graph goes and hits all of the dots, and then either goes through or bounces the way that it should. So at this point, go ahead and try the 2 I do problems, all right? Pause the video and try them. When you're done, I'm going to show you my answers for them, and if your answers don't match up with my answers, then please raise your hand so we can talk about it. I know I didn't include the degree or direction part, but just make note of, at the end, what the degree is, and then tell me what the direction is for both of these as well. So I want the y-intercept down here, so please put that. And then the direction as well, for both. So do that for both I do's. So go ahead and pause, try it, and then come back to see if you got the right answers. If not, please raise your hand. Alright, please take a moment to check your answers. If your answers don't line up exactly like mine, please raise your hand so I can come by and check your work. But I asked you to do these 2, and these are the answers you should have gotten.